Hello there. So in this video, we are going to write some recursive code. Okay. So let's quickly get started. So the first code that we are going to write in this video is going to be write a C++ code to print all natural numbers between range 1 to n using recursion. And the second code is going to be write a C++ code to find sum of digits of a number using recursion. Okay. Now we have already seen the second code using looping statements. Okay. So we have already seen how we can find sum of the digit of a given number using loops. In this code, what we are going to do is we are going to do the same thing using recursive functions. Okay, so let's quickly get started. Let's start with the first problem statement. So let me just read it again. We have to write a C++ code to print all natural numbers between range 1 to n. Okay, so let's first quickly accept value of n from the user. Okay, so let me define one variable with name n. Let me write cout. Okay, let me write cout, enter value of n. Let's see in n, and finally, okay, so now we have the value. Now what we will do, we'll just assume that we have a recursive function. Let's say print natural, and this will print value from 1 to n. Okay, so let me just pass n as the input. Let's quickly define this function. Now, as this function is just going to print the values on the screen, so it is not actually going to return us anything. So the return type of this function is going to be void. Name is print natural. It is taking one input of type integer. Let me name it as n. You can name it whatever you want. Okay, so this is going to be my function. Now always remember, whenever we write a recursive function, there are two important things that every recursive function should have. The first thing is going to be base condition. So this base condition is basically going to be a condition by which the recursive call will stop. Okay, so this will be responsible for stopping recursive calls. Okay, and finally, the second important thing that every recursive function should have is going to be recursive call. Okay, all right. Now see what we are doing. We are calling print natural function and we are passing number to it. So let's say user has entered value 5. Okay, user has entered 5 for n. So what user is expecting? User is expecting 1, 2, 3, 4, 5 to be printed on the screen. Okay. Now our function print natural is also getting argument that is 5. Okay. So its value is 5. Now what we have to do, we have to display 1 to 5 on the screen. Okay, let's quickly see how we can do it. Let's say I write something like this. Let me write cout, let's say n followed by endl. Okay, if I write something like this, let me just clear the terminal. Okay, so if I write something like this, okay, and then let's say I call the function. This is my recursive call. Let's say I call the function with, let's say, input as n-1. Right now just focus what I'm doing. Okay, actually we are not going towards the correct output. We are just trying to see how the program is behaving, and then based on that we will make some changes in the code, and then finally we'll get a code to print numbers or print natural numbers on the screen. Okay, so then I'm making a recursive call. This time what I'm doing is I'm passing n-1 to it. Okay, so let's say initially my n is 5. So in the next call, what I'm going to pass to it? I'm going to pass 4. Then next time I'm going to pass 3. Then I'm going to pass 2. Then I'm going to pass 1. And then I'm going to pass 0. Now there should be some condition where it should stop. So I will say that when my n will become 0, at that time we will stop. Okay, because we just have to print numbers from 1 to n. Here I hope you have observed that we are printing numbers from n to 1, not 1 to n. Okay, so here actually we are printing numbers in the reverse order, but just give me some time, we will correct that in, I'll say, in a minute. Okay, so what is the base condition? The base condition is going to be if my number, if it is 0, okay, if it is becoming 0, then we have to stop. So in that case I'll write return. Okay, this is going to be my base condition. Now let's quickly execute this code. Let's see what we get as the outputs. So let me just compile it. Okay, and execute it. Let me enter value of n as 5. You can see that we are getting n natural numbers from in reverse order. So we are getting 5, 4, 3, 2, 1. Okay, cool. It's quite easy. Let me quickly explain you what we have written in the code. So we have a base condition. If n is 0, then we are going to stop. So I'm writing return. Then I'm printing value of n on the screen. So whatever value of n we are getting, we are printing it on the screen. And then I'm calling the function again. Okay, so I'm calling print natural function again. So let me show you on a whiteboard how this thing is actually working. So initially I'm calling print natural. So let me just write it in a short form. So I'm calling print natural with input as 5. Now what this function is doing? So if you observe its body, you can see that it is first checking whether n is equal to 0 or not. If it is 0, then it is directly stopping over there itself, or it is returning from that function. If it is not 0, what it is doing? It is printing n on the screen. So in this case, my n is not 0. So what it is doing? It is printing n on the screen. So 5 will be printed on the screen. After that, what is happening? It is calling again print natural function with value n minus 1. So again print natural function will be called, and it will have value as 4, or it will have input as 4. Now who has called this function? Pn of 5 has called this function, or print natural of 5 has called this function. So when this function will complete its execution, where it will return, or where the control will return back to print natural of 5. Okay, so we can say that print natural of 5 is still under execution. Okay, its execution is not yet completed. When its execution will complete, when execution of print natural of 4 will complete, then and then only execution of print natural of 5 will complete. Okay, now in print natural of 4, what will happen? 4 will be printed on the screen because number is still not 0. Okay, so 4 will be printed on the screen. Now this print natural of 4 is again invoking print natural, okay, with value, okay, with value, let's say 3, or with input 3. So 3 will be printed on the screen. Again it is invoking print natural, okay, with value, let's say 2. So 2 will be printed. Again it is invoking print natural, this time with value 1. So 1 will be printed on the screen. And finally again it is invoking print natural with value, oh my god, what is happening to this n, with value 0. Now this time the base condition is getting true, or it is satisfying. Okay, so this time this if will execute, and this time we will return from the function, or I will say the print natural of 0 will terminate. So print natural of 0 will terminate, and it will return back the control to print natural of 1. Now in print natural of 1, or when print natural will get back the control, what it will start executing? It will start executing the next line which is written after the print natural call. But there is no line after print natural call. So that's why the function will terminate, okay? Or it will terminate, it will end its execution, it will return to print natural of 2. Again, print natural of 2 has got back the control because print natural of 2 has actually called print natural of 1 from its body. But as print natural of 1 has completed its execution, so print natural of 2 has got back the control, and in print natural of 2 there is nothing to execute because after this function call there is nothing. So this will keep on happening, and finally all these calls will be resolved. The control will finally come back to print natural of 5, and in print natural of 5 even there is nothing to execute. So finally print natural of 5 will give back the control to the main function from where actually we are calling print natural of 5, or we are calling print natural function. So in this way the code is working. Okay, now if we play a little with this code, we will get our expected output, and this is going to be a beauty of recursion. Okay, so let me quickly show you what a simple step I am going to do and how we are going to get the expected output. Okay, so now what I will do, instead of writing cout statement before the function call, before the next function call, what I will do, I will write the cout statement after the function call or after the recursive call, and you will see the magic. We will get the output or the desired output. So let's quickly see. I am cutting this line from here and I am writing this line after this line or after the function call. Okay, and now if I will execute this code after compilation, and let me enter value of n as 5, you can see that we are getting output as 1 2 3 4 5. Okay, by just changing the position of the line where the output is getting changed or output sequence is getting changed. Let me show you on the board why this is happening. Okay, so let me just clear the board. Okay, so initially P of 5 is getting called, correct? Okay, so initially P of 5 is getting called. Now this function, when it is called, you can see as n is not 0, it is 5, so this will not execute. Then what it is directly doing, it is again calling a next function. It is calling P of or Pn of 4. Okay, it is not printing anything on the screen. So now what is happening, it is calling, I'm not writing right now Pn, I'm writing it as P because I'm messing with n. So it is going to call P of 4. Now in P of 4, what is going to happen? Again, it is going to call P of 3. Again, it is going to call P of, let's say, 2. Then it will call P of 1. And then it will call P of 0. Now, in case of P of 0, my n has become 0. So once my n becomes 0, what I'm going to do? I'm going to return from the function. Now, once this P of 0 returns from the function, where the control is going to come back, it is going to come back in P of 1. Now, in P of 1, from this point, the control was actually handed over to P of 0. So once this P of 0 hands back the control to P of 1, P of 1 will resume its execution from the next line. So you can see on the next line, we have cout n. Okay, and in this case, what is value of n? N value is 1. So you can see that in this case, 1 will get printed on the screen. So the first number that is going to be printed on the screen is going to be 1. Okay, same thing is going to repeat now. P of 1 is going to give back the control to P of 2. Now in P of 2, once it gets back the control, it will print 2 on the screen and so on. So I hope you are getting how just by changing the execution flow or just by changing the sequence of the statements, the output has got changed. And finally, we are getting output as 1, 2, 3, 4, 5. Okay, so let me just tell you one interesting thing about recursion. Recursions actually can be categorized into multiple types. But let me tell you about two important types in the recursion or two commonly used types of the recursion. The first type is called as head recursion. And the second type is called as tail recursion. Okay. Now in case of head recursion, what happens is first the recursive call is made, and while returning or while returning back, this is called as actually stack unwinding. Okay. So this step, so we call function, we reach to the top, we reach to the max, and then the function starts returning the value. Okay. So this process is called as stack unwinding. Okay, so in case of head recursion, the actual logic of a function is executed while stack unwinding. Okay, so this type or the code that we have written just now is a head recursion. So in head recursion, we first do function call and then we write our actual body of the function which we have to execute. So because of the property of the recursion or because of how the recursive calls are made, the body that we write after the recursive call actually executes while stack unwinding. Okay, once the function starts returning or once the base condition gets hit, and then once we get back to one call back, so in that case the code execute. And the second type is called as tail recursion. So in case of tail recursion, we first write the body or we first write our logic and then we write our recursive call. So the logic actually executes when we call a function. Okay, so while going up in the stack, the code actually executes. Okay, so these are two types of recursion. So just to summarize, if you write function call over here, then this is head recursion because the actual logic that we have to execute is written after this function call. Okay, and if I write this function call after this logic that I want to execute, then it becomes tail recursion. It's quite easy. Okay, I hope you have got this thing. Let me just give you one example. Let's say you have 10 rooms, okay, in a sequence, in a row, okay, and you are going in these 10 rooms one after another. So let's say you are first entering in room 1, then you are entering in room 2, and then room 3, and so on. Now your task is actually to light the bulbs, okay, to light the bulbs in the room. So in case of head recursion, what you will do is you will first enter room 1, then you will enter room 2, then you will enter room 3, you will enter room 4, and then you will reach to room 10. So in case of head recursion, you will first reach to the room 10, and while coming back you will press the button and then you will light the bulb. Okay, so first, which bulb will light? The first bulb that will be light, or that will light, is going to be bulb of room number 10. Okay, then it will be room number 9, then room number 8, and then room number 7, and so on. Okay, so the actual task is actually getting done while returning back or while coming back. This is head recursion. In case of tail recursion, what we will do? While going till room number 10, we will light the bulbs. Okay, so first bulb that is going to be light is going to be of room number 1, then room number 2, then room number 3. Okay, so head recursion is going to be 10, 9, 8, 7 up to 1. Tail recursion is going to be 1, 2, 3, 4 up to 10. So in this way, head and tail recursion works. In case of head, we do the task while coming back. In case of tail, we do the task while going. Okay, so this is the difference. Okay, so let's quickly start with the second code. Okay, I have already commented the first code, so let's start with the second one. So the second code says that write a C++ code to find sum of digits of a given number using recursion. So let's quickly get started. Let me just copy paste few lines from here and uncomment them, and let's write a main function. So let's write int main. Okay, now let's say I have a number, let's say 1, 2, 3, 4, and I want to find its sum of the digits. Okay, so for that let me write result variable, and let's assume that there is a function called as sum of digits, and I'm passing it input as 1, 2, 3, 4, let's say, and then we'll print the value of result. So let me write cout result followed by engl. So we are interested in this function, that is sum of digits. Okay, and this will return us sum of the digits of the number. Okay, and we are just directly going to print that sum. So its return type is obviously going to be int, because the sum is going to be integer number, right? Then the name of the function, that is sum of digits, it will take one input of type integer, that is going to be number, whose sum of digit we have to find. Okay, cool. So now let's get started with our logic, okay, to find sum of digits of a number. So let me just go to the whiteboard. See, let's say our number is, in this example, our number is 1, 2, 3, 4. So we have already seen whenever we have to find sum of the digits, we have seen the logic. To get a single digit from a number, what we can do is we can take mod of it. So if we perform mod operation on the number, we'll get one single digit, that is 4. Okay, and let's say I'm maintaining a sum variable, so I can add this 4 to that sum variable, and my sum will become 4. Okay, now as we have already added this 4 into the sum, now let's modify the number, or let's remove this 4 from the number. So to remove this 4 from the number, we will divide it by 10. Okay, here we are taking mod of it by 10. Here we will divide it by 10. So once we divide it by 10, the number will become 1, 2, 3. Same again, let's take mod with 10 of this number, and we'll get answer as 3. So we get one digit of a number. We can add this to sum, and the sum will become 7. Okay, let's take division of it by 10, and we get number as 12. Okay, now after getting a new number, after getting it, we'll again apply the same logic. So we'll take mod by 10, we'll get 2. Okay, and then we'll divide it by 10, we'll get 1. I hope you remember this logic. We have seen it while learning the same program using looping statement. Okay, and then again we'll add this 2 to the sum, so our sum will become 9. and finally we have this number left. We'll again take mod of it by 10, so we'll get digit as 1, and once we divide it by 10, we'll get digit, or we'll get number as 0. Once we get number as 0, we can say that number has exhausted, or we have got all the digits of the number, and obviously we are going to add it to sum, and finally the sum is going to be 10. So in this way, this logic works. Okay, now let's do the same thing using recursion. Okay, it's quite simple. See, what we can do is sum of digit. So let's return its value. What is going to be sum of digits? So I'll say sum of digits are going to be, sum of digits of a number is going to be, I'm going to say number mod 10, okay, plus I'm again going to say sum of digits of number divided by 10. Very easy, super easy. I'm going to tell you why we are writing this statement. See, what we are saying, sum of digit of number. So let me just show it to you over here. See, initially from main, we are getting called to sum of digits. Okay, I'm going to write it as SD. Okay, and let's say the number is 1, 2, 3, 4. Now once this sum of digit 1, 2, 3, 4 is called, what this is going to return? It is going to return 1, 2, 3, 4 mod 10. So it is going to return 4 plus sum of digits 1, 2, 3, because we are writing sum of digit number divided by 10. Okay, so it is going to return basically 4 plus sum of digit 1, 2, 3. Now again we are calling this sum of digit 1, 2, 3. So now what this is going to return? This is going to return 3 plus sum of digit 1, 2. Now again sum of digit is getting called with value 1, 2. So this is going to return 2 plus sum of digit of 1. Finally, this sum of digit of 1 is getting called. So what this is going to return? This is going to return 1 plus sum of digit of 0. Okay, and finally, once this sum of digit of 0 is called, we will stop the function, or we'll stop our recursion. Okay, and finally, once the number is 0, it will return, let's say, 0. Okay, so now as it has written 0, we got the value for sum of digit of 0. So this will be 0. 1 plus 0, it will be 1. So sum of digit of 1 is going to be 1. It is going to be, let's say, 3, and so on. Okay, so in this way the recursive logic will work. So we have recursive logic, we have a recursive code, and let's just write a base statement. So our base statement is going to be if my number, if it is 0, in that case I'll just stop. So I'll write return 0. Cool, it's quite easy. Let's quickly execute this code. Okay, you can see that we are getting output as 10. So if you calculate sum of 1, 2, 3, 4, the answer is 10. Okay, so in this way the code is executing. I hope you are very clear with the idea about how the recursive function works, how we can write any program. Actually, we can't write any program using recursion because sometimes it can become a little bit tedious. Okay, so we can write some programs that do show recursive nature, or that do have some recursive nature. So such programs we can write it using recursive logic. Okay, so I hope you have understood how we can write recursive logic. I hope you will keep in mind that base condition is very important and recursive call is very important. Based on the position of the recursive call, if it is at the top or at the bottom, the recursions can be categorized into two categories: head recursion and tail recursion. If we are writing recursive call at the top and doing processing at the bottom, it is head recursion. If we are writing processing at the top and doing recursive call at the bottom, then it is tail recursion. Cool. So I hope you enjoyed watching this video. Thank you so much for watching.